Good morning all the students. So we are back here again with one more new video. In this period we will be talking about the nature of the CX bond, or you can say the RX bond. RX is nothing but the alkyl halide, where R is the alkyl group and X is the halide group. So let's see what all things we are going to see in this period. In this period we'll be looking for the nature of RX bond, or you can say nature of CX bond, right? So we are going to see the CX bond. So let's look at this CX bond. You all know that C stands for carbon and X stands for halogen. Right? C stands for carbon, X stands for halogen. So we are going to see the bond between the carbon and halogen. Right? So when we talk about the CX bond, this CX bond is a highly polar bond. Right? It is a highly polar bond. Why it is polar? Because carbon develops a slight positive charge and this halogen develops the slight negative charge. Why it happens? As we all know, X is nothing but the fluorine, then chlorine, bromine, iodine and astatine, right? So this is our X. So in this X we know that X is nothing but highly electronegative in a nature. Highly electronegative in nature. Right, my dear students? So here this X will pull the shared pair of electron towards itself, and due to which the carbon will develop slight positive charge and X will develop slight negative charge towards itself, right? So that is why we say that this particular CX bond is a polar in a nature. Now in this case you have to remember that X is nothing but it can be fluorine, chlorine, bromine, iodine and astatine. So here we can say that this bond develops a dipole-dipole moment, right? Or what does the dipole-dipole means? They are developing the charges. So due to this development of the charge, there will be slight positive charge on the carbon and there will be slight negative charge on the particular X, that is the halogen atom. So you have to understand this question, nature of RX bond or a nature of CX bond, which is very, very important and it is asked many a times in the board exam. So let's go further, my dear students, and let's look at the size. Let's talk about the size of the atoms. Now when we talk about the size, as you all know that as we go down the group, what is the trend? As we go down the group in the group 17, we see that the size goes on increasing. And what happens to the electronegativity? As we go down the group, electronegativity goes on decreasing, right? So my dear students, you have to remember this trend. It can be asked in the board exam, right? As we go down the group, size goes on increasing. Then as we go down the group, electronegativity goes on decreasing. Now as we know that as we go down the group, electronegativity goes on decreasing. So what will happen? This CX bond, if the bond is formed between chlorine and fluorine, this particular CF bond will be considered as most polar in a nature. It will be the most polar in a nature. Why it will be most polar in a nature? Because fluorine, what is fluorine? Fluorine is highly electronegative in a nature. Fluorine is highly electronegative in a nature. So you have to remember that the one which will be highly electronegative in a nature, it will be most polar in a nature, right? I hope that you might have understood this. Okay, based on this, we can also classify this bond into three types, or we can call them as the bond parameters, right? We can classify them into three types. So what are these bond parameters? Number one, it will be bond length. Number two, it will be bond enthalpy, or you can call it as bond energy. And number three, it will be dipole moment, or you can simply call dipole moment, right? So here in this case, what is the bond length? First we have to understand what is the bond length, right? Bond length is nothing but the distance between the radius of a one atom to other atom is called as bond length, right? This is called as the bond length. Distance between, or distance from the radius of a one atom to the other atom is called as the bond length, right? Then what is the bond enthalpy? What is exactly the bond enthalpy? Bond enthalpy is nothing but also called as the bond energy. The energy, the amount of energy which is required to break the bond is called as the bond enthalpy, right? So what is it? The amount of energy required to break the bond is called as bond enthalpy, or we can also call them as the bond energy, right? Then what is the dipole moment? What is dipole moment? Dipole moment occurs between the covalent bond or the ionic bond. Dipole moment occurs between two covalent bonds or two ionic bonds, right? So you have to remember this. Now why this dipole moment occurs? It occurs due to the difference in the electronegativity. As I told you, why dipole occurs? Dipole occurs because there is a difference in the electronegativity between the two atoms, right? So you have to remember this bond parameters. You can give the heading this as the bond parameters. Bond parameters of CX bond, right? That is the carbon and halogen bond. Now here when I talk about the CX bond, we have to understand the bond length properly, right? So what is the trend of the bond length in this particular CX bond? The bond length depends upon the size. So what happens as we go down the group? The bond length increases. Why the bond length increases? Because the size goes on increasing. So as the size goes on increasing, the bond length will also go on increasing. So you have to understand that the bond length goes on increasing as we go down the group. As we go down the group, right? So you have to note this. It will go on increasing. Then what about the bond enthalpy? What is the trend for the bond enthalpy? See, the bond enthalpy